Hello viewers, so we have this question under kinematics that was under motion in one dimension. So it's saying a car moving along the x-axis starts from the position x1 is equal to 2 meters when t1 is equal to 0 and stops at x final, which is equal to minus 3 meters when t final is equal to 2 seconds. A, find the displacement, the average velocity, and the average speed during this interval of time. B is saying if the car goes backward and takes 3 seconds to reach the starting point, then repeat part A for the whole time interval. All right, so let's go ahead and solve it. Let's see what is happening here. So according to what we are given, let's use a number line to represent what we are given here. So let's say we have this as our number line, and this is 0. Here we have 1, we have 0.2, we have 0.3, and 0.4. Then here we have -1, we have -2, like that. Then we have -3, like that. Let me just rewrite that. -3, like that. Then we have -4, like that. All right, so this is what we have. Let's say this is distance in meters. So this is distance in meters. All right. So what we are told here is the vehicle is starting at, when time is equal to 0, its position is at 2 meters here. So its position is at 2, and then when time is equal to 2 seconds, its position has changed from 2 to -3. So in other words, the movement of this car is from the positive to the negative. So it's going in the negative x direction, from positive 2 to -3. It's moving like that. So its movement is from 2 going this side up to this point here, which is 0.3, like that, -3, like that. So it's moving from point 2 to point -3. The first question is saying, find the displacement. Now, displacement is just change in position, the overall change in position. So you can see from here to say it moved, it changed the object or the car. In this case, the object we're talking about is the car. The car was at this point here. So let's show that the car was here, and then the car is now here. So we can see it has changed its position from this position here to its new position, which is this point here. So the overall change in position is what we call displacement. So how do we find displacement? Displacement, using a formula, we'll say displacement. Now I'm going to use S for displacement. Displacement will be equal to x final, the final position, minus the initial position. So the final position minus the initial position. Replacing with what we have there, the final position according to what we are given here is -3. So we have -3 meters. And then this must be subtracted by the initial position is 2. So 2 meters. And when we when we subtract -3 from -2, what we are getting is -5. Yeah. So the displacement that we have here for this car is -5. That's the answer for the first part, which is the displacement of the car. So let's go ahead and look at the second part, that is saying the average velocity. How do we find this average velocity? What is average velocity? So average velocity of an object is just the overall change in position over the overall change in time. So we'll say average velocity. Let me just create space for that. So we'll say average velocity represented by this is equal to, in this case, we'll have the change in position. So that is the x final minus the x initial divided by time. The time also is t final minus t initial, like that. So replacing with what we have there, our x final is still minus 3 meters, and then minus 2 meters, because 2 meters is our initial position. Then this will be divided by t final is 2 seconds, then subtracted by 0 seconds, because our initial time is 0 seconds. So this will just give us, on the other side, we'll have minus 5 meters, and this will be divided by 2 seconds. So what we are getting is minus 2.5, and this will have the units of meters per second, since we are talking about velocity. So this is our answer for the second part, which is saying the average velocity. Our average velocity is minus 2.5 meters per second. So after finding that, the third part is saying average speed during this interval of time. So we need to find our average speed. So our average speed, V, is equal to, we have distance over time. Now speed is a scalar quantity, so we are talking about just distance over time. And the distance covered from the initial point to the final point is 5 meters, because we have a movement from 2 to minus 3, and we established to say that it was 5 meter that was covered. So the distance covered is 5 meters, and the time used is still 2 seconds. So this is 2 seconds here. And when we do our mathematics, we are still getting 2.5 meters per second. So our speed is 2.5. Let me just write that one properly. So it's 2.5 meters per second. So this is our speed. Now you may be wondering why we have the same values for average velocity and also average speed. So when the distance covered is the same as the displacement, it means we're going to have the same value for velocity, average velocity and average speed. Since the distance that we covered here is equal to the displacement, the change in position, it means we're going to have the same value in terms of the speed and also the velocity in this case. So the difference now is speed is a scalar quantity, so it doesn't show direction. That's why we have a 2.5 meters per second here. But velocity is a vector quantity, so it showed the direction. The negative that we have here is showing that we moved from the positive to the negative x direction. So this is the negative we have here, because velocity is a vector quantity. And we have it as a positive here because it doesn't show direction, simply because speed is a scalar quantity. So that's what we have for those two. So this is our average speed, and this is our average velocity, like that. So let's look at the last part of the question, that is saying, if the car goes backwards and takes 3 seconds to reach the starting point, then repeat part A for the whole time interval. So let's redraw our diagram. All right, so we have our diagram there. Now, the first journey is from this point here where we have 2 meters to this point that we have is minus 3. Now they are saying if the car repeats or goes backwards from this point to its starting point, then we should repeat what we have done for part A, meaning we need to find the displacement, find the average velocity, and also find the average speed during this time interval. So let's show that. So it means now this is moving from that point back to this point now. So this is again another starting point going backwards. So now let's answer the question. We find the displacement. What will be the displacement? Now, from the definition, displacement is change in position. Okay, so it's change in position. If we are moving from point A to point B and then back to point A, it implies to say we haven't changed any position. In other words, if we're at this position here, let's call this one point A, and then we have this point B. And then we are moving again from point B back to point A there. What this implies is we are cancelling our change in position. We moved from point A to point B, and then we are going back to point A. So this movement that we have here from this point to this point here, and then from that point to the beginning, it means we have cancelled our displacement. We can still show it in formula form where we are saying this displacement represented by S is equal to x final minus x initial. Now this is going to be equal to the x final is 2 meters and the x initial is also 2 meters. So 2 meters minus 2 meters, this is going to give us 0 meters. So there is no change in position for this object. In this case, we're talking about a car. So if it goes back to its original position, it implies to say its displacement is equal to 0. So that's the answer for the first part, which is displacement. Then the other part is saying the average velocity. Now, average velocity, again, we say this average velocity is equal to still x final minus x initial, and this is going to divide by the t final minus t initial. So replacing what we have there is we still have 2 meters minus 2 meters, and this is going to divide by, now the initial time that we have here is still 0, and the final time now, we remember, is coming to point B and going back to point A. It's using 2 seconds to go to point B and using 3 seconds to go to point A. So the total time used in this case is going to be 5 seconds. So still we're going to have 0. This will be equal to, on top we're going to have 0 meters, then divided by what we have down is 5 seconds. But then 0 divided by anything is still going to give us 0. So whenever we don't have displacement, it means our velocity is going to be 0 as well. So this is also 0 meters per second. So we have 0 meters for displacement. We also have 0 meters per second for average velocity. Now, the average speed doesn't consider displacement. Average speed is talking about the overall distance covered divided by the overall time used. So what we are going to have there is speed is equal to distance over time. This is equal to the distance covered now. Remember, we are now moving from point A to B and point B back to A. The distance that we have here is the same. So from point A to point B, we covered a distance of 5 meters, and then back to point A, we covered another distance of 5 meters. So the total distance now is 10 meters. So on top here for distance, we have covered 10 meters distance, and this would divide by the total time used going from point A to B. We used 2 seconds. Coming back to point A, we used 3 seconds. So that's now 5 seconds used. And when we divide 10 by 5, we're getting 2. And this will have the units of meters per second. So our speed is 2 meters per second. Our average velocity is 0 meters per second, and our displacement is 0 meters. So this is how you solve this question. If you found this video helpful, subscribe to our channel, comment, and invite your friends to do the same.